Hi, welcome to this short demonstration showing Fabricate being installed and run on top of Google's container engine. We'll be showing the CD features using Jenkins pipeline as well as centralized logs and metrics. We're going to start from the Google container website. We've already logged in, so we get taken straight to our dashboard. From here we can create a new cluster. We're just going to start off with doing a 3-node cluster, which is probably a bit excessive for this demonstration, but we want to show that we are running in the full cluster here. For demo purposes, we're just going to speed this up a bit as well, but really wanted to show end-to-end, starting from zero, going right the way through, creating the platform and installing and running the Fabricate applications on top. So this is sped up in real time. I think it took around 4 or 5 minutes, so it's a real easy way to get up and running with Kubernetes. Once the cluster's been created, we need a few details so that we can log in from our local machine and be able to start interacting with the platform. This is the API server, the endpoint, and we're going to use the kubectl binary to be able to authenticate and then interact from a terminal session from our local machine. So we need to get the authentication details as well. The username is admin. We get the password from our Google Container Engine dashboard. We run these in our terminal, and we can see that we can now interact with the platform. These are our this is our 3-node cluster that we've just created. Next, we want to be installing and running Fabricate. By default, Fabricate starts with a number of default applications that enable the continuous delivery features out of the box. We can run this go fabricate binary and go fabricate deploy. Because we've already authenticated using kubectl, we know which server we're pointing to and the authentication details to use as well. Once we deploy this, we're actually installing a number of application templates that from the Fabricate console shortly we'll be able to run our one-click installs. We're going to install and set up a number of other configuration that are required by Fabricate. Under the hood now, this is requesting a number of applications being started. And if we look at the pods, we can see the containers being created, and the Fabricate console has already been pulled and run. We can access the Fabricate console by using the Kubernetes service proxy. So we can open this in our browser using the same credentials that we had from our dashboard. We can log in and we get taken to the Fabricate console. We're now looking at a number of namespaces at the bottom, and at the top we have our team dashboard running currently in the default namespace. Now if we go to the overview page, on the left hand side we can see these are the Kubernetes resources that we can click and view and then perform actions against. We have an overview page where we can see these are the pods and applications that have been started by default. From the pods view, we can see we've got GOGs for our Git hosting. We can access the logs, and we can actually SSH into the pods as well from here. We can see we've also got a Nexus being started for Java apps that get built and dependencies can be cached. We've also got Jenkins being started and the local Docker registry as well. We've also got a content repository too. We can see these applications are just being pulled now. Jenkins is started. Now these are the default applications that are started when we run Go Fabricate. We can see the Jenkins instance has been started. We're using external load balancer by GKE, so the IP addresses are automatically created for us, and the console then is able to redirect to the individual applications. Now these are the one-click installs that we mentioned before. You can see here we have a number of default applications that can be run. There's the Jenkins, we have a lot of different applications. But from here we're going to run the management app. This includes our centralized logs and metrics. So with one click we can actually install and wire together Kibana and Elasticsearch for our centralized logs, as well as Prometheus and Grafana for our centralized metrics. Click run, and these will then get scheduled in the default namespace as well. Slightly sped up here as well, you can see the time ticking away there, but for the demo purposes just wanted to save time. So now we have Elasticsearch cluster running. We can also now navigate to our Grafana and Kibana. Out of the box, Fabricate comes with a number of dashboards, so that we have camel routes, a HA proxy, we can see our Kubernetes cluster metrics, we can understand the health of our cluster. This is all out of the box. We'll see the memory usage and consumption from our 3 nodes. Scroll down, Kibana is just waiting to be, the Docker images are being pulled and started. Now that the pod is running, we can also view our centralized logs. Again, similar to Grafana, Kibana comes with out-of-the-box dashboards, so that we can view our logs, our centralized logs. Nicely parsed as well, so that we have powerful searching. Now that by default have all the applications that are used to build and release our software, we've also now got our management, so we can understand the health and how things are running. We're now ready to be able to build some applications. Using the Fabricate console, we have a wizard. We can run a number of quick starts to help us start with our projects. We've got Django, we have Golang projects with Spring Boot, Python, Swift. We're going to start with an integration project. This is a Java project based on the Camel integration framework. By selecting the type of application we want to build, we now get taken to the selection of our continuous delivery pipeline. This is our Jenkins pipeline that we're going to choose. There is a default set of libraries that we use from Fabricate, but these are able to be extended and improve and use for your own and customize. We will want to copy our Jenkins pipeline into our source code, and once we hit execute, under the hood, Fabricate is creating the project in Gogs. It's created our Jenkins jobs, wired them together with webhooks. Jenkins has now detected there's a new project and has kicked off a build. Now Jenkins master is now interacting with Kubernetes to be able to schedule a brand new Jenkins agent, which then also in turn uses a build pod containing the build tools in order to build our application. It's an extremely scalable way to be able to build and continually deliver our software. So the Canary release has started. Under the hood we're going to be doing a release, a Maven release. The first time it runs, because the Nexus instance was new, we'll actually need to cache a lot of these dependencies. Subsequent builds will actually run a lot faster. Just to make things a little more interesting, we can view from our dashboard that we have our demo int, as well as our environments that have automatically been created. These again are customizable, these are just some defaults, and you can actually order these so that your promotions between environments work. From our apps page you can see the URL for our Gogs repository. This is be copied from our IDE or your terminal to be able to then pull the source code and then push changes back to. So we're going to run also a Node.js application. One of the misconceptions I think from Fabricate is that it's just focused towards Java applications. In fact, anything that runs in a Docker container can now be built and run in a consistent way. We can see by selecting our pipeline, our Jenkins pipeline, we're having a consistent way to be able to build our software. So this is going to be a testing, staging, approve and promote pipeline. So we now have two applications that have been built using the quick starts. Going back over to our integration project, what this is actually doing is performing the Maven release. It's also using Fabricate tooling to be able to build a Docker image as well as automatically generate the Kubernetes resources under the hood to be able to run and request and run on Kubernetes. If we head over to the project, we have a nice wiki within the console that allows us to be able to quickly view the source code that we've been created from our quick start. We're running a Spring Boot application here, as you can see from the annotation. And because it's a camel project, the console has detected this and allowed us a nice wiki to be able to add components and add routes for our enterprise integration patterns. We're going to speed this up slightly because of the dependencies that are being pulled down. And this will, as I said, generate the resources automatically, the Kubernetes resources to be able to run. It will then automatically deploy into an integration test environment, run some integration tests. Providing that's successful, it will automatically deploy to a staging environment. We can see our pod is now being started because it's blue. It's waiting to be started. Once it turns green, it will be running in our staging environment. So now everything is running and deployed in our staging environment. We now have we can look at the docs that we've been generated. This is a Maven site. Over time, this will be more in our content repository. Everything, in fact, we'll need to be able to make well-educated decisions of our approval processes. For example, automated release notes and test reports, for example. We have a metrics link as well, so that we can actually be taken in using Grafana for our centralized metrics and look at the health and understand the health of our application that's just been deployed in our staging environment. Here, because it's a camel project, we've got our out-of-the-box metrics showing the camel exchanges as well as the camel processing time. Now we can head back to our application dashboard. From our staging environment, we can actually now go directly to the pod and actually have a look at it running in its environment. We can see this is our demo app, integration app, running at the top. Underneath, you might notice our Node.js app has already been built and deployed. So because we're on our pods view, we can see the logs. We can also, as it's a Java application, use JMX and Jalokia to be able to zoom into the pod and get our real-time visualizations from our camel exchanges. Here we can see the exchange count incrementing and going through our content-based router to do different log messages. So from our application dashboard, the intention is that we have everything from here that we can actually link to be able to approve our project for our deployment. So the last thing we look at is our centralized logs to make sure that our application is logging correctly so that we know that if anything is going wrong, we can actually diagnose problems. By searching using Kibana, we search for int, which is our project name, and we can see our Spring Boot application is running in the default staging environment and logging correctly. We expect there to be a number of different approval processes going forward, but from here we can actually approve the promotion into our production environment from the Fabricate console. Under the hood, this has actually approved the stage in our Jenkins pipeline. Similarly now, similar kind of view, we have our Node.js application. Now this actually has a web endpoint, so it has a link to be able to see the application running in the staging environment. The Node.js, Golang and Swift examples are all have a similar approach. They have a simple web endpoint that we're able to hit. So now that we've verified that's running okay, we approve again and has a deployment into our production environment. Just for completeness, let's go and edit the Node.js application in our wiki. This will actually commit the changes to our Git hosting under the hood. And the Jenkins will recognize that there has been a new commit and then automatically trigger a subsequent build, which will then release and deploy automatically into our staging environment. We expect the number of applications, the number of microservices to grow significantly, tens, hundreds, thousands even. So we want to be able to have decent amount of visualization and charting around our applications in our different environments, so that we can have a handle of what's actually deployed and what version at what particular time. Now the speed of this was actually a lot quicker for our second Node.js build. We can see if we go to our application dashboard, we are performing a rolling upgrade in our staging environment because we have built automatically our new version. We use Git shards for non-Java applications for our versions as well. This is performing a rolling upgrade. New pod is started, the old pod is taken down. This is the Git shard. We don't actually click this in the demo, but that would actually show us the diff of the changes. And here we can see our Hello San Francisco welcome message that we've edited. To do something slightly different, let's abort this change so that we don't actually deploy it into our production environment. And we can see that we have our two different versions running in each environment. Centralized metrics is extremely important to be able to understand the health of our applications running in each environment. Let's head over to the staging environment and we can see our integration project. On the left hand side we have our memory usage, and then on the right hand side our CPU usage. Not for this demo itself, but there is a significant difference in the resources being used between the Java and Node.js applications, something that might be quite interesting for people in the future to look at. Here we can see there's two Node.js applications. That's the old application and the new version that we've just deployed. Now, we can head over, we have our centralized metrics, but we also want to understand the events from our environment. This helps us understand and continually improve. We want to be able to visualize events, the number of deployments and builds and other aspects of our continuous delivery pipelines. Here, this is all out of the box charts that we provide here, and then we will grow over time. We can see the number of deployments per application. This is the number of builds per application between our integration project and our two Node.js applications builds. On the bottom left hand side now we have a builds pipeline chart. This actually shows us which builds were successful. We have an aborted one there in the purple. We can also see our logs per application per environment, and on the bottom right hand side this is the approval wait time per application. We want to understand any manual activities within our continuous delivery pipelines, how long our manual activities take, and try and identify areas where we may be able to improve processes. This is the Fabricate console with continuous delivery enabling continuous improvement on Google Container Engine. Thank you.